Okay, so ladies and gentlemen, we are finally ready to introduce to you our speaker of the night, Shahin Farshchi, whom many of you know. Those present in the audience, I know that there are some friends, and that's always good. For those of you who doesn't know Shahin that well, he is quite an amazing guy. He is an engineer in his background. He um, is an electronic engineer with a background in computer science, and he has a PhD in this field. And he did a lot of work in both industry and academia. Then he switched to venture capital and continued his successful endeavors there. So we invite him to tell us about his achievements and his way to where he is right now, and to share with us some advice, hopefully, or how we all can achieve this height. And we'll be just sitting easy in our chairs and chatting, and you guys will be welcome to join us with your questions a bit later in the meeting. But first, as I said, what would be very interesting for us to learn is that making the path from an engineer to a venture capitalist is not straightforward and not easy. And you made it. There are some people who made it before you, like Eugene Kleiner, who worked in Fairchild Semiconductor and then became a founder of Kleiner Perkins. But there are not that many people who did that. So, will you please tell us about your path?
Sure. So I can start off with my path and maybe take a guess at your answer. So I started off as an engineer. Ever since my days as an undergraduate, I was always enamored by venture capital, the whole notion of creating big companies, helping visionary entrepreneurs basically go from inception idea to billion-dollar business. And my I guess my guess was that in order to become a credible VC, you'll have to start many successful companies and then transition to that VC role as a successful serial entrepreneur to be able to better assist and guide those entrepreneurs, those aspiring entrepreneurs. So after finishing, during my undergrad, I took a class at Berkeley. I did undergrad at Berkeley. Um, and it was a new venture initiation class that was taught by VCs. And it was interesting to see how these VCs looked at things. They took an approach by taking pattern recognition as it applied to building and growing multiple businesses, more so than drawing on their personal experiences actually building companies. So it kind of dawned upon me that having the kind of the experience seeing companies grow, seeing companies come in, present hypotheses, those who get funded, trying different things along the way, and having a large sample set of those, maybe more like a physician, like a teaching physician. A teaching physician has to see patients in addition to teaching. You don't see these kind of physicians just teaching and just doing research and not seeing patients. And I saw venture capital kind of being similar in a sense that you have to see a lot of companies come through the door in addition to the companies that you're actually helping grow, and have the operational experience to be really good. It can't just be, just looking at deals, just helping companies, or just being an entrepreneur. It's a combination of all three. So with that in mind, I went to graduate school. In between undergrad and graduate, I thought I'd to try my hand at a large company. I'm a huge car enthusiast, and I thought I'd try my hand at the car business. So I moved out to Michigan, worked for GM, and realized that it's one thing to love cars. It's another thing to be in the car business. It's kind of like loving, the arts and television and movies and actually working in Hollywood. They're two very different things. And and I quickly realized that, having been kind of grown up in the Bay Area, I'm not kind of designed or tuned to be in the car business. So I came back to California, went to graduate school, did a PhD, and during the course of my PhD, well, I selected my PhD advisor because he's a very entrepreneurial guy. The course of my PhD, we started a company, and it was more of a kind of a contract R&D firm, but it got me exposed to the whole notion of raising capital, hiring people, basically being able to sell a vision to people who otherwise weren't really getting paid to work really hard to help build the company. And those are valuable experiences for me and great for the people that I work with. We raised some money primarily from the government, created a business, but it wasn't a kind of the kind of business that all of you guys that are here in the room are trying to build. It wasn't a big business. It didn't have the legs to be a big business. But in that process, I got to know VCs. And one of the VCs I got to know was Lux. And at that time, they were in New York, and they were looking for somebody in California with a background like mine in kind of semiconductors and electronics. This is back in 2006, 2007 timeframe, and there was very much a personal fit. Because keep in mind that venture capital, unlike big companies, are very kind of personal organizations. You need to function as a small team very effectively. Teams that are otherwise kind of spread out, individuals that are very busy doing different things, and need to be effective as a small group. So it becomes a very personal kind of dynamic issue more so than skills and expertise. I'm
It's like
sure
that
that
famous two pizza rule when you have to be able to group small enough to have two pizzas for lunch and that's enough for everybody.
exactly, exactly. Everybody has to be able to eat the pizza, enjoy it, and go on about their tasks. So it was, I'm sure there are many people that were more qualified than me, both from a business standpoint, from an engineering standpoint, from a experience standpoint, that probably couldn't have filled the role that I was able to fill. And again, it kind of goes back to who you are, the kind of personal makeup and the dynamic of the organization that you're joining. So it just so happened that I was at the right place at the right time, and I was a fit for this growing firm. But again, it's not like engineering or any kind of very specialized task where if you can, design circuits or if you can do qualifications or if you can write code that does a certain thing, then you're a fit for these certain tasks. It's a lot less structured and a lot more subjective than that.
Yeah. So, which were your first experiences in investing? Which companies did you work with?
Sure. So going back to your previous question, as a graduate student, you're trained to formulate hypotheses, ask questions, and test those hypotheses. Now, as a PhD student, it was more along the lines of designing circuits and seeing what you in silicon. When you're out in venture capital, it's about more about kind of business models. It's about testing, applying certain technologies to different areas and seeing if you can build a business out of it. It's about trying to put different types of people together with different backgrounds and see if they can be effective as a team. And so that kind of model, albeit in a very different setting with a different kind of in a different discipline, yet kind of the same pattern was applied. So we were looking at different business models and with different technologies and different areas, again with different types of people, going into different markets. And a lot of these hypotheses obviously didn't work.
Such as?
Well, I can. How much time do you have?
Just
but,
give us
I don't think we have that much time. But like, there was a bunch of hypotheses, for example, in the clean tech space. There were many, many very talented scientists with great ideas, with great teams of engineers who had many years of experience in the kind of semiconductor manufacturing space, applying those disciplines into thin film solar. And the reality is that there were fundamental issues that prevented the success of those companies, and it primarily went back to the availability of capital to scale up those manufacturing processes to the point where they can compete with effectively what comes out of the ground, which is oil and natural gas. So it was a more of an economic challenge more so than a technological challenge or a fundamental business challenge that made companies I guess unsuccessful. And I guess Solyndra is one example, which is down the street from here.
You're tempting me to skip the questions I prepared, ask you totally different questions because you raised the issue of existing resources versus resources created by new economic model. And in robotics in particular, we are dealing with the same issue, the existing resources of
Yep.
human labor
Yep.
and automation that's created by robotic technology that is supposed to replace the existing resource, which could be cheaper or more readily available, just like with hydrocarbons versus solar.
Sure.
Is there a relevant comparison?
I would say yes. A lot of roboticists. How many roboticists do we have in the audience, by the way? Okay. Maybe let's take a step back. How many people in the audience have already started a company? How many are aspiring to start a company? And how many are not interested, not with a, haven't started a company, or not with a startup company, or do not plan to start a company? Okay, all right, just one person. Okay, okay. Um, well, I guess so. So so the gentleman who is neither, what are you kind of, what is sort of your area of interest? Okay. Okay. And for to guide their career path. Okay, got it, got it, got it, got it, got it. Good, you're in the right place. So, so robotics, in my sort of view, although I'm sure many people in the audience may disagree, is still somewhat of a nascent field. It's a combination of AI and machine learning, mechatronics, you know, I guess manufacturing kind of technology to kind of bring down the cost of the devices. It's sensing technology, actuator technologies. There's all of these things that in some sense have been applied to different applications in the past, but are now coming together in this kind of new field that we call robotics. So if you would have asked somebody maybe 10 years ago, what would you call what's a robot? There would have been the science fiction answer, which is, the R2D2s and the C3POs, but there would have been the real robots, which are the Kuka Fanuc, ABB kind of arms that are on manufacturing lines. But nowadays, the cool robots are no longer those $100,000 things that are in cages that turn, that dip, car chassis into, for example, anti-rust chemicals. They are the C3PO garage, PR2 robot style machines. And so, that whole discipline is starting to come together, and the people that are coming out of that discipline are looking at robotics as more of as a consumer product, more so than a device that's purchased by an enterprise to to accomplish a certain task. Right now, there are some companies that are trying to make robotic arms, for example, that would replace kind of people and that are doing kind of very mundane tasks. For example, flipping things around or doing basic inspections. But a lot of the robotics people, a lot of the people that are doing robotics now, to your point, the aspiring PhDs and the young engineers thinking about developing robotics that would replace basic human tasks or augment humans, or help assist the elderly, or help with search and rescue. And they watch the DARPA Grand Challenge, and those are the types of robots that they're more interested in making. And so I think, given the fact that the technical challenge is still very high, there's a lot of emphasis on being able to overcome these technical challenges. And there is an assumption that once these technical challenges are overcome, then there is going to be a natural kind of market opportunity. And the reality is that that's normally not the case. And so the big challenge that I'm seeing is that, I'm seeing very, very talented roboticists making really interesting, shiny objects,
Right.
because it's so hard to get there. So I give that to them. But then, it's very difficult to take that shiny object and make a rationale as to how do you make a business out of this. If you think about iRobot, iRobot has been around since when? Since like 1990. And they were making specialized robots for the military for many years, until the early 2000s, when they kind of tested out a few things, and the Roomba was one of the kind of consumer products that they kind of tested and tried out, and they've become one of the few kind of successful robotics companies. Systems, Kiva didn't make a box, or a robot with, like, that beeped and kind of rolled around. They solved a very, very specific problem as it related to logistics, and they weren't making a robot. They were trying to solve a reliability problem. They solved the reliability. So Kiva is not the result of a fancy robot that does something that no other robot has done before. They're able to take a existing kind of, I would say, paradigm, and make it reliable and make it useful. Now, was it worth the $800 million dollars or whatever it was that Amazon paid for them? I don't know. Who knows? I mean, maybe, maybe not. But the reality is that they were solving a very, very specific problem to suit a very, very deep-pocketed group of customers, and they did that successfully. But unfortunately, the majority of robotics companies that I'm seeing, unfortunately, have been developed again by extremely talented people solving very hard problems. But the challenge that I'm facing, as the champion trying to get my partnership excited about investing in these companies, is being able to articulate that path as to how this really amazing product will turn into a billion-dollar company. I'm sorry, I was trying to change my flight earlier, and now their computers crashed while I was trying to change my flight. Anyway, now they're calling me.
You want to answer that?
No, it's okay. Worst case, I'll be stranded in San Francisco, which isn't the worst thing ever. But
Well, we have food and drinks, so
yeah, and I can just maybe lay out maybe sleep in your offices here. I'm just kidding. I live in Palo Alto. So anyway, so that's sort of the challenge. I don't know if that answers your question, by the way.
well, it it answers in a way that the challenge is there.
Yeah.
The solution is not still available. I mean, we're still going to
Well,
work on
a
it,
lot of
right?
people can get rich. The
Yeah,
person that comes up with that answer is going to get very rich. That's for sure.
that's great. Speaking of, investing in robotics is not an easy thing to do. In hardware in general, it's more difficult than say in the next iPhone app, right? So, what is the difference in investment cycles in the whole approach? What do you look at the different components of this the usual set of team, product, market,
Sure.
or do you look at it differently?
Yeah. So as a rule, VCs generally hate multiple dimensions of risk. They like to take risk on a technology, for example, with the expectation that the team can execute on the business and the market will accept this product. They like to take a risk, for example, on a team, but with a proven technology, with for example, a huge market. Although the team risk is one that they typically would not like to take. Normally, it's a product risk or a business model risk, but not a combination of the two. And typically, VCs, especially our firm, really bets on the team. We want the team risk to be minimal, which is when I say team risk, I mean the faith in the founders to be able to execute on this plan and to be able to recruit amazing talent that's smarter than them to help them execute on this plan. So now the question about hardware. What makes hardware difficult? Hardware is difficult for many reasons. First reason is that the time constants or the cycles are long, right? And the amount of money that you need to be able to get to a, whatever you want to call it, the minimum viable product or the first prototype is long. I mean, you can have, four Stanford undergrads bang out an app in a week, for example, and they basically use LAMP, just get something out there that works pretty well for a minimal amount of money. Good luck doing that, in any aspect of hardware. Even if you're soldering stuff together, it'll take a lot of time and it'll take, months perhaps and, many, many thousands of dollars to get you to that first kind of proof of concept. And that kind of, and this challenge basically continues to scale throughout the life cycle of the company. So if the first prototype took 5 times longer and took 5 times more money, getting it to production will take many times longer and much more money than it would an equivalent, for example, software product. So that's one major challenge. The second major challenge with hardware is that it's very difficult to iterate, right? If you get let's say if you're making a gripper robot, a gripper device, if you get this gripper, qualified, and if you get into production, then if you want to change some aspect of it, then it's going to take time and money to basically be able to make that change because there's a huge fixed cost associated with getting that product to where it is. And software, obviously, making changes isn't as challenging. And then in the case of hardware, you need a very kind of diverse skill set and set of, I would say, relationships in order to succeed, which probably isn't as much the case with the more traditional kind of software companies. The types of people that you have to recruit and hire, the types of people that you have to work with, the people that you have to partner with. It's a very different kind of community. And again, the expense and the time cycles are longer.
How much longer? And on the average?
So, I can give you an example. So, in the case of semiconductors, so, I have a couple of, well, we have a few semiconductor companies, and it took on the order of tens of millions of dollars for them to get to their first product on the market. And they were not even selling those products profitably. They're selling both the ones that I was very close to were selling at a loss initially until they could scale up and get to the point where they can start selling with margin, let alone be able to sell with healthy margin. Um, so again, the economics are somewhat against you. This doesn't really apply to software companies, which is why you see the vast majority of VCs up and down Sand Hill putting a lot more emphasis on software
Hmm.
than on hardware. Now, there's tools that are available to us now, the prototyping platforms, the contract manufacturing options in Asia that are accelerating this process and reducing the costs and the barriers associated with getting something out there. But again, what's available to you is available to your competitor, so it's not like as though it's a free lunch in that sense.
Okay. So, if I were to go into venture capital, you would want me to stay away from hardware
No,
then?
I mean, I think I would,
Yeah.
I would be very careful.
Yeah.
Most hardware companies require significant capital.
Uh-huh.
I think semiconductors are the extreme because you have to hire very specialized people. There's an enormous fixed cost associated with getting a new chip out that doesn't apply to all hardware, obviously. Um, but companies with shelf parts face their own challenges. It's not like as if it's just limited to semiconductor companies. Um, but again, I would be very, very cognizant of the cycles, of the revisions, and of the costs associated with all of those um, for getting your product out. And then again, how do you map your product, your gadget, to a company? Another challenge with hardware is that there are certain metrics that are used for SaaS, app, kind of enterprise software companies that unfortunately are very difficult to use for hardware companies. So I'm not sure how much of you in the audience, if let's say it's an app, it's the number of downloads, it's the monthly, weekly actives, right? It's the amount of in-app purchases and how those purchases are growing. So these are very, very well understood kind of, I would say, performance indicators that would lead you or your investors to believe that there is a growth path in front of this company. And there is an N of hundreds of these types of companies that you can kind of draw upon as evidence to basically see how the companies are doing. There isn't that much of an N in hardware, right? As a hardware, let's say if you're making a pick and place robot, right? You know, how do you know your business is really doing well? How do you know if you're really on that path? How do you know that you're at the knee of the J curve? It's very
Yeah.
hard to tell. Because again, there aren't that many pick and place robot companies that had X dollars in bookings and X dollars in sales and X dollars in service revenue or whatnot, service contracts to be able to really say, okay, well, here are the other companies that were kind of where this company is, and from based on these, with this level of, I guess, certainty, we can guess that this company is also kind of on that track. Metrics don't exist in the case of SaaS. It's your MRR, your churn, your sales your sales revenue per sales rep. Again, there's all these metrics that are used, so it makes the VC's jobs a lot easier. Not to say their job is easy, but it makes it more straightforward to invest in those kinds of companies than it is for hardware companies that also have this added challenge or the added challenges that I talked about earlier.
Yeah. But at the same time, we see that in the first 2 months of 2015, there was huge amount of investment in robotics in particular,
Yeah,
almost comparable to the whole amount for the 2014 in
sure.
just 2 months. So what's going on?
So
Are we
you should
blowing
look at
another
that.
bubble?
Yeah, you should look at that. No, I wouldn't use the word bubble, but I would say that you should look at that and reference the amount of venture investment that was made as a whole. So what was the percentage of investments made in robotics relative to the percentage relative to all investments, from a dollar amount or number of deals made. Now, I will tell you that there is a significant number of investors out there that are trying to put capital to work into this theme that they call robotics that they want to be part of. And I would be wary of those investors. If you're talking to an investor that doesn't really understand your business, really understand the challenges that you're facing, and doesn't have a good sense as to where you're going as a business, unless there is a relationship, then I would be careful. Um, I would kind of think, I would kind of take a step back and think, well, do I really want to work with this? Do I want to have this person as my partner? Um, in our firm, we place a lot of emphasis on our confidence in the entrepreneur. One example, I just helped put together a company, in fact, and brought in the CEO. He was one of the founders of, so basically there's 5 or 6 billion-dollar semiconductor IP companies in existence, right? There's Tensilica, Cavium, Rambus, Imagination, and ARM, right? But he was the founder of one of those companies. And when he said that, oh, this piece of IP, this semiconductor IP company could become like one of those other billion-dollar companies based on my, decades of pattern recognition, then we said, great, let's build this company together. Because we believe in the technology, we believe in the technologists, but we were wary of the long tail of hundreds of semi-IP companies that many of you guys may have not even heard of, right? That are kind of these like small mom and pop shops right now. They don't get anywhere because it's very difficult for them to achieve scale. I mean, for the same reasons that I've mentioned as to why it's hard for robotics companies to achieve scale. We invested in a company called Sci-Fi, a drone company. Helen Grenier, she was one of the founders of iRobot. And the reason why we funded that company versus the dozens of other, maybe hundreds of other drone companies out there was because she was applying pattern recognition based on how she built iRobot from effectively nothing. She was one of the founders to the company that went public in 2003 or 2004 and where it is today. So again, it's really relying on the entrepreneur's pattern recognition and different view of the world and a hypothesis as to why they think that this approach that they're proposing will work, whereas so many others have failed. Because it's fair to assume that you're not the first person that came up with this idea, and you have to go back and think to yourself, why is this going to work where it otherwise hasn't? What do I see that others don't see? And convince yourselves, because if you're able to convince yourselves, you're definitely able to convince a VC who's certainly not as smart as you.
Hmm.
That was supposed to be a joke, but okay.
Well,
VCs are not very smart, but anyway.
I don't know. Wouldn't comment on that. There is another field that interests me enormously since my childhood. I grew up on science fiction, robots and space flight, right? So space, final frontier. We're getting there now, and we're getting there through private businesses, which I think is the way to go. And also, I think that this is a perfect intersection of two applications because it's much easier to do many tasks in space with robots than with humans.
Sure.
So, are you doing anything in that direction? Are you involved with any companies that do
Yeah.
that? And is there anything we should look for?
Sure. So the answer is yes, I 100% agree. I mean, so my personal view, and I don't want to disappoint anybody, but my personal view is that humans shouldn't be in space. I don't see any reason why we should put a person at risk and put them into the, all the radiation and all the, crap that's out there when you can just send a robot to do whatever a human's supposed to do. If it's supposed to be shaking an alien's hand, well, we'll have the telepresence robot shaking the alien's hand or whatever it is. Or if it collects samples from asteroids or, whatever it is, I think robots should be doing it. Although it's cool, I mean, there should be space tourism and all that kind of stuff. But I don't see a reason why humans should be getting on these big, whatever spaceships that are, climate controlled and whatnot that protect their occupants and shooting them across the galaxy. So I 100% agree. There should be robots designed to conduct whatever tasks that we want to perform in space. So we are invested in, well, at least two companies that I can talk about. One called Planet Labs, and they are basically applying cell phone components to Earth observation satellites. So they're using the components that you'd find in your cell phone, putting them in a shoebox size bus.
CubeSat format?
CubeSats, correct. and they are doing what billion-dollar kind of digital globe satellites would do, but with $20,000 CubeSats. So they have the biggest constellation of any kind of spacecraft company in orbit today, and they will be taking daily images of every point of the surface of the Earth for agriculture, finance, insurance, mapping, all kinds of different applications. We're invested in another company called Orbital Insights, and what they're doing is taking data that's collected from the likes of Planet Labs, also from other satellite constellations, from drones, and creating actionable signals from that data. So signals to insurance companies, signals to financial institutions to buy or sell. So it's number of cars in Walmart parking lots, level of oil in number of ships in port, number of containers on ships in port, number of containers on port. So they're taking that data and providing actionable insights or actionable signals to them. So those are the two kind of space. Third company, actually, which is also related, is a metamaterials company making phased array planar terminals for satellite communication. So right now, if you've looked at Southwest airplanes that have little domes on them, that's to be able to encapsulate a moving gimbal-mounted terminal to communicate with satellites for in-flight internet. Our company Kymeta is making an iPad form factor replacement for those mechanically moving antennas using phased arrays in the Ka and Ku band. So phased array is not a new concept. When you look at these antennas that are along the 101, those are basically phased array antennas. But for cellular, they're using technologies to do phased array beamforming for satellite communications. So yeah, we're very interested in satellite space. And if anybody has a in the space or space arena, and I also grew up on science fiction, so it's probably one of the reasons why I did engineering, and would love to.
And your dad worked in NASA.
My dad, yes. So my dad, he's a mechanical engineer. He worked at NASA down here. That's why I grew up here, and going to work with him and seeing these jet engines on test stands was always really a lot of fun for me, and so that's what kind of got me into engineering.
They were developing shuttle here, right?
They were working on, he wouldn't tell me exactly what he was working on, but it is military stuff basically. Yeah. But I would see a lot of parts and a lot of stuff laying around, so I wouldn't ask too many questions.
Okay, but we will, and I will in particular. And the question I want to ask is, what are the secrets in the field? What are the trends that nobody knows about? Where should we concentrate our efforts?
Yeah, that's a good
how
question.
we are going to get all reach
Yeah.
on these new trends.
So,
Tell us, please.
yeah, so having been an academic myself, for me, it was all about pushing the technology envelope, right? Building something that nobody has built before. The reality is that if you look at the successful ventures, companies, like Tesla, like SpaceX, like, iRobot, their success wasn't the product of a capability that nobody had done before. Sure, the whole notion of, obstacle avoiding, whatever, robots that kind of find their way and pick up, dust, that's not a new concept. But iRobot was able to market it and productize it and monetize it, right? So, I like to use the term impedance matching, right? So to be a great technologist, you have to push the envelope from a technology standpoint. But pushing the technology envelope doesn't necessarily translate to impedance matching that incremental or even quantum leap in kind of technology to an interesting business, a large business, right? So in order to do that, you have to impedance match the need with the tool set that's available to you. Now, sometimes you're like Elon Musk and you create a new rocket engine or you create a new battery management system to be able to disrupt and create an attractive business that would leverage that innovation. But it's usually less about kind of that, the hardcore technology innovation, which is what roboticists do, right? So roboticists are focused on, what we're told when we're getting our PhDs is what you're doing is so important that you're going to change the world by pushing the state of the art, right? And that's what kind of compels us to sit down in labs underground for 5 years, spend 5 years of our lives under there not getting paid or getting paid $20,000 a year to do that. That's the motivation. But that's it's not quite true, right? At the end of the day, you create something, but it's not really useful to anybody unless unless either the government, for example, develops it further, or somebody turns it into a company. So somebody can do that impedance matching function. Now there are academics who've been able to do both, invent something and turn it into a great company, but that's rare and very
It
difficult.
is.
So I guess the secret is, to answer your question, the secret is to, identify a need, identify a white space that has dollars attached to it, that has people that have deep pockets that want to pay, and see what I mean. It doesn't necessarily have to be a bleeding edge technology. See what's out there that you can integrate and solve their problem without having to spend a ton of money to get you to the point where you can have that kind of initial, I guess, proof of concept for them to be able to play with and use, and then slowly, engage further with you. So, for example, if you want to remove certain aspects of human labor from Flextronics manufacturing lines, so right now there's people standing in stations like phone booths flipping circuit boards, right? If and putting them into different trays, for example. If you want a robot that does that, come up with a way to use the best available technology and minimize what you need to invent, and just find the cheapest, fastest way to get something into their hands that they can play with, and find a way for them to engage with you. Okay, and then from there you can work with them and get a better sense as to what the larger opportunity really is, and then you can use that as proof behind your hypothesis as to why this can be a large company, and then you can take that to investors should you choose to take their money, by the way. In my opinion, only a small fraction of successful businesses really make sense for venture capital, because with venture capital you're putting 10, 15, 20, 30, 40 million dollars to work to really accelerate a company quickly, and that only applies to companies like Pinterest and Uber and Twilio, are these companies that achieve massive growth. The reality is that most areas that robotics is getting into, manufacturing, let's say, healthcare, these are slow industries. And so, you know, automotive manufacturing. I mean, these are industries that don't that if you pump venture. I used to call venture capital money like steroids. If you pump steroids into it, it's really not going to take it very. It's not going to go very fast. So it may not be the best kind of fit for venture. But then if there's an area that you've identified that can grow very quickly with the help of venture money, then absolutely, we'd love to talk to you.
And on more of a personal note, being a car guy myself, if you were just graduating college today and to go and work for Tesla instead of GM, would you do that, or is
In a
you?
heartbeat. In a heartbeat. So I work for GM. I was working out of a old furniture store, and the thing was, it was one of the biggest buildings I'd ever seen in my life. By the way, massive in suburban Detroit. It was across. So there's a GM Warren Tech Center, and it seems like a relic from the 50s. You can totally tell that in the 50s, this was one of the most like it was like the Google equivalent of the 50s. But you can just see the decay when you go in there. Anyway, so I was in the reliability physics kind of department in this kind of extension to the tech center that was across the street from the tech center, and man, was it depressing. And so I would walk in, like the paint and the like nothing really matched, and it was just obvious that they were like trying to cut costs. I mean, this is in 2001 kind of time frame. Anyway, so we were sitting in these cubicles, and then like we had meetings all around, suburban Detroit. We were in cars, stuck in traffic all the time, and it was just like such a depressing job. Then I went to Tesla, and they had their engineers actually sitting in the plant, and so I toured the plant, and there was Elon's office, and his office was pretty much embedded with the engineers in the plant, and to the complete opposite of how it was like at GM. It was a place I really want to be in. Like even as of now, I wouldn't mind, you know, taking a job, for example, at Tesla today, because it was just such a rich, dynamic environment, which unfortunately the big three, at least at GM, just didn't exist.
Okay. Well, I think that I monopolized you with my questions long enough, and now it's time to let the audience do their share. If you still have a few minutes,
Sure.
so it's for us now. We
I'll let you.
no, we
Sure.
we have a microphone here, and that's what those of you who want to ask questions are going to use.
Please speak into the microphone.
Can I hold
That's what it's for.
it? Thank you very much for the talk. You did mention about the technological issues to surmount in this industry. Can you name the top three?
So I think vision is a big problem. Um, I think cost is a big problem. Cost associated with the physical robot itself. I think motion kind of planning and unstructured is a different one, is a big problem. And I think the cost of deployment and operation. A lot of robotics companies that I see require a trained technician to operate. And if you're trying to replace minimum wage labor with this exotic robot, then the value proposition, is somewhat, it defeats the purpose, right? So today, people, unfortunately, roboticists don't really, I buy my iPhone, I take it out of the box, my mother who can barely even really see very well can take this thing out of the box, turn it on, and use it, right? And so for robotics to become more mainstream, even in the enterprise, you need to be able to plug it in and have a person that doesn't even have a bachelor's degree, maybe with a AA degree, to be able to use this without having to call, support every few minutes. So it's making it brain dead. I think is another one of the challenges.
Thank you.
Next.
Well, thanks for the fascinating talk and insights. Very nice. Do you have any angle of robotics that you think would be profitable as a VC? Maybe software angle?
So, I don't want to, completely discourage you guys from doing a robotics company. I guess the point was to be mindful, right? To be mindful of the cost, mindful of the time, mindful of the time it takes to get to a product, time that it takes for that product to gain adoption, and how that would, and how when you take at least venture money, the clock starts, and you and your VCs making money depends on how quickly you can kind of achieve your goals. It's not a matter of if, it's a matter of when. So, particular angles, again, to the earlier questions that were asked, if you can make conventional robots, I can give you an example. So I invested in a company called Plethora, right? These guys are based in San Francisco, and what they're doing is making mid-scale and small-scale kind of manufacturing as economical as large-scale manufacturing. So if you want to have a part, at a certain, for example, let's say $1 each, you don't have to wait for 3 months and deal with a contract manufacturer or whatnot. You can have it done immediately at their facility in San Francisco, and they're using entirely kind of off-the-shelf robots and off-the-shelf, CNC machines to do the task. So to answer your question, if you can leverage as much as you can, leverage existing technology as much as you can, and focus on integration to make it more useful, I think that would be a smart path for a venture backable startup, in my opinion.
Another question?
May I jump again with a question of my own?
Sure.
You mentioned integration, and I was thinking of all the supporting infrastructure that has to come with any technology.
Sure.
Do we, at this point in time, have enough of that? Is there any particular sector of it that requires maybe contribution of bright minds to improve that infrastructural support for robotics for hardware businesses in general? Like the contract manufacturing is one of the aspects, but 3D printing that came up so popular lately, and maybe open source approach to robotics. Is there something there?
I mean, ROS, for example, is a huge resource, right? I think, unfortunately, I'm not a robotics engineer myself. I mean, that's a question for the audience, probably. Like, what tools would make your lives easier? What tools will help you make robots or design robots faster? What tool would overcome this kind of time problem, this cost problem? that I brought up. What's the equivalent? So if you look at the LAMP stack, for example, right, for developers, that made creating a mobile or SaaS kind of application extremely fast and extremely cheap. You don't have to license or buy a bunch of software. You don't have to buy servers. You can just use LAMP, turn on Amazon, and you're good to go, right? So what is that? What is the equivalent of that in robotics? ROS, maybe somewhat.
Qualcomm's operating system.
Yeah, so the Snapdragon platform, sure, maybe, but what are the equivalents that would really make the job of a robotics designer as easy as a mobile app or a SaaS application designer?
Hmm?
Yeah. So is it because there aren't enough people doing? Go ahead. Microphone.
Thank
Like you mentioned, like don't try to invent something new, and it should be useful for a guy. It should be very easy for a guy to use. That's the main thing that is impeding this industry right now. And ROS is a good example of that. It's so bulky to implement. It's not easy to use, and the company that makes those robots, it's so huge, it's like $10,000 or $20,000 robot. You can't make use of it in any house or any industry anywhere at all.
Right. Right.
That's what is wrong with this industry right now. They are trying to do too much, which not many of us can use actually in real life.
Yeah, I mean this is kind of like the dawn of the PC age, right? I mean, back in the 60s or 70s, if anybody wanted to make a personal computer, they had to buy all the parts and do everything from scratch. And then when you had when some folks reverse engineered the BIOS of the IBM PC, then things started getting easier, right? And then developers didn't have to be computer engineers to be able to make stuff that didn't make. Then you had sort of, what was that first Kleiner company, the bank computer company? I'm it started with a C or something. Anyway, I'm blanking. But folks were able to make computers that did interesting stuff. They could focus on the function. They could focus on the market. They could focus on the business more so than the technology. But right now with the robotics guys, there's so much, there's no tools, to your point, that they have to focus on the technology. There's not enough time to kind of really be able to understand the market and the dynamic and do that impedance matching. Whereas if the tools were available, they could then focus on the impedance matching more so than the technology, the basic technology. I mean, there's a company called Modbot, for example, that's trying to integrate the controller, well, I guess the gearbox and the driver and the kind of sensors that go into a robotic joint and make it a modular, kind of arm. So you don't have to go in and kind of build all of that yourself. You can kind of use their focus on programming the arm to do interesting things. So they're trying to be one of those kind of components in that stack to make the roboticist's life easier, so not have to reinvent the wheel each time.
Is there a big potential market for someone in this field?
So, I mean, if you look at software, right, I mean, there were a ton of people that contributed to these stacks, these tools that are being used by developers. Now, did all of them become billion-dollar companies? I mean, there was MySQL, there was, I guess Red Hat for Linux, there was, there were companies, there was, what was that, not SourceForge, obviously, but the other one, GitHub. So there are some tools that help people that became billion-dollar companies, and there are a lot that didn't, right, that remained as open source projects and that weren't monetized. Now, were they not monetized because the people behind them weren't smart enough, or they weren't ambitious enough, or the technology just didn't, it wasn't something that could be monetized? Who knows, right? But we know that some people did create billion-dollar companies in that process of making the tool sets, and a lot of people didn't. And so, is there a formula? If I had that formula, I'd be on my private jet right now and be worried about changing my flight. So.
I have a question. Do you have an opinion or perspective on all the capital influx last few years in the IoT, IoE space, in the industrial, medical, consumer?
Yeah.
I mean, are these real problems that are going to be solved, or everything will shake out, in your opinion, over the next
I
year?
call IoT old wine in a new bottle, right? I mean, like, you've been around. I mean, like it's one of. I mean, we this is the same story kind of playing over itself, right? And everybody was talking about RFID, right? Back in the kind of late '80s, early '90s, mid '90s. Oh, RFID is gonna be like, you know, RFID has become ubiquitous, right? Everybody in this room benefits from RFID. Billions of dollars were lost in the process of making that happen. So we all benefited, right? We as consumers, the enterprise customers that are using the Walmarts of the world are all benefiting, but the investors and the entrepreneurs did not benefit. So you should not conflate benefits with making money, right? Um, so that was the kind of the first generation of IoT, right? Then there was Gen 2 RFID, and then there was Smart Dust and Zigbee and all these companies that kind of popped up in the early 2000s as a result of microcontrollers getting really cheap. So they said, like, why deal with the passive kind of RFID tag when you can have an active piece of sand, for example, that communicates and tells you the health of a bridge or the health of the windows, or like you can just you can spray these things everywhere. I mean, I don't know if you guys remember the stories, but people are talking about just spraying sand everywhere, and they're all going to make a mesh network, and they're all going to talk to each other and tell us what's going on, around us in a ubiquitous kind of embedded fashion. They call these wireless-enabled embedded sensors. There was, wow, I can just go through a list. There was Scintilla, Crossbow, Motive, Ember, Dust Inc. I mean, all these guys raised maybe over $200, $300 million collectively. And investors and the entrepreneurs didn't make a dime. I guess the most notable exit in that cohort was Ember, and that was acquired by, I think it was Intersil or one of these semiconductor companies, for like $70 million. And I don't think anybody made money on that deal. And they were only acquired for their Zigbee radios, right? And when we talk about IoT today, there's really no new fundamental technological capability. They're taking all this off-the-shelf stuff from Marvell, Broadcom, Qualcomm, and making gizmos that do stuff. But it's going to be the Nests of the world that make a very attractive product that the market picks up. It's going to be the Beats of the world. I mean, those are going to be the successful IoT companies, not gadgets and widgets that do some novel functions. Because I guess history has proven over and over again that simply tracking stuff and being aware of stuff and making smart networks of stuff is not a means of making money, for at least for investors. But then sure, the public may benefit the way RFID did, but billions were lost in the process.
So probably if somebody comes up with an interesting implementation of the existing technology, or maybe a revolutionary business model for their
Sure.
there.
I mean, if you would have asked me about smart thermostats in 2007, I would have said serious. But then they pulled it off. Tony Fidel was able to pull it. That's what goes back to investing in people. I mean, he was behind the first iPod. He had a great team of people behind him. He actually recruited one of my buddies when he was getting started. He wouldn't tell him anything about what they were building. But my buddy came back and said, "Man, I'll quit my job for this guy." And he ended up actually, so Tony ended up not taking him. But had Tony decided to take him, he would have quit his job. I think he was at some NVIDIA or something at the time, because he was just he was so impressed by him. And so people, like Tony, like Elon, that can attract amazing people and have interesting ideas, can pull stuff like this off. But to say that we're going to make a widget that's a little bit better than that other widget, that I kind of doubt will go very far.
Yeah, even though we see plenty of it happening in the mobile app space.
That's different. I mean, you're kind of throwing kind of
Darts.
the spaghetti at the wall and seeing what sticks,
Uh-huh.
right? So it's a consumer play. And the reason why that's feasible is because you can fund dozens of these things, and one of them takes off, which is why I'm actually relieved that our fund doesn't do anything. So we do not do social, local, mobile, Uber for X, Airbnb for Y, find a parking spot, find a date, find your friends. Like, we don't do any of that kind of stuff. And to your point, a lot of money is going after it because there are big wins. I mean, the entire venture capital kind of establishment exists because of the likes of Facebook and Twitter and these types of companies. But that's not what we do. And there are people that are very good at that, by the way.
Just a second, I'm on my way.
What about mobile apps that interact with things?
Yeah. So I think that's interesting. But the emphasis should be on, in my opinion, by the way, should be on sort of the unique capability and the unique experience you're creating. So, I actually funded a company that is taking, for example, they're using so a bunch of Stanford machine vision guys, and they're taking videos that are captured by, and they are making they're automatically, so what you would otherwise do behind Final Cut, stabilizing the image, taking out the junk and turning it into something presentable and interesting. They're automating that whole process. So it's an app, but it's an app that kind of interacts with a thing, which is the camera on the drone. So yes, I think that is interesting, but again, it goes back to experience, what you can enable, and again, what would drive value for the company. And so the reality is that what drives value for those kinds of things is number of users, engagement, activity,
Yeah.
unless you're charging for it, right? Which is a different story.
You just mentioned drones, and on kind of a different aspect, we just saw the FAA legislation on drone use, and there are will cause the brain drain that people who want to work on drones will just find a way to do it someplace else, just leave the United States and go to, say, Brazil or China or Russia or someplace else where there is no prohibitive legislation. Do you see any kind of similar concerns with legislation as to robotics that might happen here, or in that
Yeah.
aspect where more?
I mean, the reality is that drones are robots. They're flying robots, right? So, I mean, it's such a broad term. Is there going to be legislation around, the AI? I don't know if you guys have seen AI. I'm sure if you're sitting here, you've seen AI. But those types of robots, probably. But I think that's a good problem to have. I mean, if you develop a technology that gets to that level of attention, like drones, like robots that may think, to be honest, I think if you're at that point, then it's probably a good problem, in my opinion. How it's going to play out, if you look at history, at the end of the day, especially in America, things have worked out for the better of the broader kind of population as a whole. If you look at I mean, like if you recall, like when cars first came out in the UK,
Yeah.
I don't know if you guys remember this or have heard this story, but it's pretty funny. So if you wanted to drive a car, you would have had to have a driver, an engineer in case the car would explode or to keep it from exploding, and a guy walking 50 feet or something in front of the car to make sure the car doesn't roll over anybody.
Yeah.
So they imposed that regulation, and as a result, what happened to the UK car business?
Well,
They said, we're going to America, we're going to work for Henry Ford, right? So, I mean, many people look at that, and it probably is a no. I mean, if there's something that can really make an impact, then I think the concern, like, whoever it would be that would be standing in front of it would move out of the way really quickly, kind of given that history.
Yeah. Peter Diamandis a couple of days ago was answering the question about drones. Said, "Screw FAA, drones will fly."
Yeah, I mean, it's going to happen. I mean, the technology is going to get to a point where, I mean, there's going to be bounds. You can't fly. I don't think we'll be able to ever fly a drone over SFO, for example. Like, we're not going to be able to fly drones around the White House and whatnot. But I think there's going to be legislation that, makes it the same way we have, cars driving around everywhere. And I mean, I think a 16-year-old driving a car is pretty dangerous, but it's legal, right? So, if a 16-year-old can drive a car with 300 horsepower that weighs 2 tons, then I'm pretty sure that we'll find a way for drones to fly as well, safely and legally.
Thank you very much. What do you think about the future of the personal assistants? Will we have a robotic assistants or a personal artificial intelligence in 5 or 10, 15 years?
Yeah.
What are your thoughts on that?
I think elderly care is going to be a huge driver. I mean, I think as, like our generation, We want to, people want to, as the generations kind of, as we kind of move along, people want to be more independent, longer, and maintain their existing kind of quality of life. And I think for that, you absolutely need robots. Now the question is, what's it going to take? And I think robots have to be robust. I think it's robustness, really. I mean, like, I would always use the Kiva example, right? Kiva, those guys, Raf and his team, Mick Mounds and Raf, they made a robot that did a simple job, but did it reliably with, like, with a mean time between failures of whatever months, whatever that number was. And so I think that problem needs to be solved. Does it have to be like a C3PO robot that dances and sings and does all that kind of stuff? No, but it has to be something that does it has to be a robot that does a very simple task reliably and cheaply. And so if we can solve that problem, if we can find out what that task is and how it can be done simply, how it can be done reliably, in a robot that costs as much as a phone, for example, then I think that would be interesting.
Thank you, sir. You spoke about metrics, yeah, in the SS industry, the apps industry. There are a lot of standardized metrics. With your experience in the robotic industry, would you have like some emerging metrics that can be standardized for?
Yeah,
robotics?
I think for robotics, like any other kind of business that's selling kind of durable goods, it's going to be, booking, sales, revenue, margin, cost of sales. It's, kind of your administrative overhead, how much it costs you to sell every unit. I think it's at the end of the day, it's going to be those kinds of metrics. It's not like the Facebooks and Twitters of the world where you can make no money, but still be valuable because of these metrics that folks have invented based on kind of pattern recognition, right? But who knows? If you would have asked somebody in the dawn of the internet, right, back in 1992, hey, a company's going to be valuable, even though it makes no money, but it's going to be valuable because it has downloads and it has active users, they would say, are you smoking something? And so, there may be a time that, there may be metrics that we can't even fathom over here applied to robotics, but but probably just don't know them right now.
So I have a question, kind of piggybacking off of this gentleman's question, as far as drivers for robotics. So I'm interested to know your thoughts about perhaps like environmental drivers. So for instance, I just came from New York, but I hear that there's a lot of drought that's happening over here, and something people talk about a lot, and they're affected directly by it. So things like climate change and drought. I mean, arguably, an app isn't going to fix that.
Yeah.
However, something like a good robot can. So that kind of societal kind of value proposition is existent. So I was just wondering your thoughts on that.
So, not to, I guess, I think in one issue with agriculture is that that kind of time constant issue is exacerbated because you have seasons, right? So people want to see the effect of your technology over many seasons to be able to basically correlate your technology with better yield or whatever kind of advantage that you claim to have with the technology. That's one challenge. So not to not to say you shouldn't go after that space, but I mean, we already have robotics in farming. Tractors are pretty much robots, right? Farmers sit inside them, they hit a button, and the thing is able to do whatever it's doing within a centimeter of accuracy. So that technology, I think, already exists there, and the entire field as a whole is very open to robotics and automation. The challenges that you have over there, just to be mindful of, is that you have 2 or 3 companies that own the channels to the farmers. It's Trimble, Caterpillar, Deere, I'm sorry? Yeah. So it's those guys that own the channel to the farmer. So if you have this whiz-bang technology and they have some legacy technology that sort of does the job, but not as much, and they see you as a threat, you're not going to get in. You have to be either significantly better or have one of these guys behind you to be able to get in. And I've looked at a bunch of companies doing everything from kind of service, kind of surveillance to monitor hydration of the crops and be able to optimize fertilizer usage and all that kind of stuff. And at the end of the day, they're having challenges getting to the farmers because they need to go under the banner of Deere, Caterpillar, or Trimble.
And what about perhaps a robotics company that's dealing with, say, climate change in the construction industry? Say, these industries that perhaps didn't necessarily have any kind of robotics in them, or at least.
So I think if you want to do any kind of, I wouldn't look at it as a robot solving a problem. I would try to understand the basic fundamentals of their business and the drivers behind their business. Like, what are the very, very basic metrics that underlie their business, right? I mean, and for construction, it's pretty obvious, right? You have an investor that puts up money for the project, and that investor is looking for IRR, right? It's very simple. And then you kind of go backwards from that. So what affects IRR? It's time. So can you build this thing faster, right? It's obviously it's money. So how can you cut costs? It is, and so what, then you look at money. Well, what's money a function of? It's a function of labor. So how can we reduce labor, right? So you kind of look at what you're try to understand what you're solving for, and then work backwards, and then see how an automation solution can affect that kind of end goal in an obvious way. If it's something where the contractor's going to have to say, oh, let me try it out and let me see, it has to be a no-brainer for them. It has to be obvious. If the value proposition isn't obvious, kind of towards solving that end goal, then I would look somewhere else.
Yeah. And probably to follow up on the question that was asked, speaking of environmental factors, robots are quite useful in dangerous environments where humans have no place of being, to start with.
Yeah.
Mining,
of course.
space.
Yeah. So again, I would look at the because I mean, mining. I don't know about space, but mining is also a very sensitive kind of process, right? It's very sensitive to dollars spent, right? So kind of again, I would break down those economics to see how you can impact those economics with an automation solution. So again, we don't want to be making robots for the sake of making robots. That's if we want to do that, we should get academic jobs. But if we're looking to make robots to solve problems, again, we've seen the people who've done a good job and have built value, really understood the problem, identified a very, very acute problem and solved that problem well.
Excuse me. What do you think about the sensors market? There are forecasts that there'll be like 1 trillion sensors by 2020 or so, and it's very much related to Internet of Things. Sensors are deemed to be like a kind of a new nerve system of the world.
Yeah.
Do you believe in these forecasts, or what do you think about this?
I think the people that do the forecasts are smart. I always discount the forecast. If it's a Gartner forecast or something, then I always kind of divide it by 2 or maybe divide it by 10. But it's still a pretty big, if you divide it by 100 even, it's a big number, right? So I would be very, very careful with sensors because at the end of the day, it doesn't matter whether the sensor is generating it's reading based on 1,000-year-old technology or based on bleeding edge, space age technology. At the end of the day, it's generating a reading. So, your, let's say, a crystal oscillator, right, can be using some kind of an atomic clock inside, right, and generating that pulse signal, or it could be using a quartz, piece of quartz, for example, right, and generating that signal. At the end of the day, it's generating a signal that has to meet a certain band, a certain requirement, and who cares, right? Or if you're sensing temperature, or if you're sensing vibrations, or if you're sensing light or whatnot. So if it's a very, very basic sensor, then I would make sure that 1 degree, whether it's cost or it's sensitivity or it's reliability or stability or whatever it is, signal to noise is 10 times better in 1 or more angles before even considering making a new sensor. Okay, and then there's algorithms, right? There is this ImageNet benchmark. Has anybody heard of ImageNet? So ImageNet is a benchmark for deep learning, right? So this group out of NYU, for example, broke the record, and then Google broke their record, and then Baidu broke Google's record, and then Google, I guess, broke their record again. You know, you can have the best algorithm on earth, but you're going to be beaten at the end of the day. Somebody's going to beat you. And so it's that impedance matching. How do I take what I have, make sure that I'm always going to be better than everybody else, and build a business around it? So CDMA, for example, kind of boils down to an algorithm, right, that Qualcomm developed. But they quickly took that algorithm and turned it into a business and were able to create a business for themselves that was defensible. They weren't just coming up with modulation schemes. If they wanted to stay in the modulation scheme business, probably nobody in this room would have heard of them by now, right? But they took that invention and they came up with a way to turn that into a business. Does that answer your question?
Yes, thank you.
Anybody else?
How do you feel about the surgical robot?
We feel
Intuitive
very
surgical?
excited about it. We actually funded a surgical robot company. And again, this goes back to the founder. So the founder of this company founded Hanson Surgical, Intuitive Surgical, and now this company. And so,
Do you mind stating what the name is?
the company is still stealth right now.
Oh, okay.
Okay, but you'll hear about it. But at the end of the day, it's about a visionary who is able to really, again, identify the problem specifically, and then build a solution to be able to serve that specific need that they've identified, and have, again, the relationships and the kind of experience to be able to kind of chart that path versus throwing money at the problem and hiring engineers on the object that nobody really cares about, right? So the answer is yes. We're excited about surgical robotics. Yes, there's a huge challenge associated with making any kind of impact or change to the standard of care. But we've seen that hospitals and provider groups that employ surgical robotics are at least in higher demand by patients, even though there's not a whole lot of data to show that patients have better with surgical robotics. But the expectation is that that's going to change. I mean, before, driving cars was less efficient and more difficult than getting on a horse. But that obviously changed in time.
Well, with some of the Da Vinci robots, what I've heard is they sit in a closet and they don't get used.
But they're great marketing, right?
So they're not really solving a problem other than making money.
Well, the expectation is that they're making money, so that's nice, right? If they're making money for their customers and for their investors, the public, then that's good. But again, it's going to take time until that benefit to the patient becomes known and becomes established.
Hi, thank you. I just want to piggyback from her question in regards to surgical robotics. It seems like, as far as the imaging and the resolution, when high definition first came out, it seems like there was like Da Vinci and Intuitive that first jumped on high definition. Nowadays, it seems like a lot of these surgical OEMs aren't interested in higher resolution. So when it comes to some of the new sensors that are putting out 4K, or some of the new sensors that are 5K by 5K, they're not interested, just basically because the field of view and the limitations.
Yeah. So I mean, that kind of goes back to the question that was asked about sensors, right? So if the data, or if I would say the accuracy, right? Because at the end of it, it comes down to accuracy, right? If the accuracy that your sensor is providing isn't creating a net benefit for the function that you're trying to accomplish, you have 4K, 5K, 10K, but if it's, for example, be able to find the tumor or be able to cut the tumor any better towards impacting patient outcomes at the end, if that path isn't obvious, then it's that's not that application is not going to be interested at the end. I mean, even if, still with all these fancy robots, to the point that was made earlier, there's still no clear benefit to the patient, but it's a great marketing tool for now. So when you go down to the sensor level, again, like there has to be a clear use case for the person that's making the robot. That hey, going from HD to 4K, is it going to help this robot do this task better, right? And usually you're constrained by the resolution, the precision of or the accuracy of the arm more so than you are the sensor. I'm just guessing, and that kind of places a limitation as to how much they can benefit from the added kind of sensitivity of sensors, including the image sensors.
Yeah, that was precisely my question. Do you think the absence of a good actuator, which is also cheap and good, that's impeding the whole industry?
Yeah, I mean, I think I think actuators are good today, but they're expensive. I mean, if you want a joint that that has that kind of whatever the backlash and the accuracy and all that kind of
And
requirements.
it's also cheap.
And cheap. I mean, those don't exist, right? Like
Yeah.
a robotic, like an arm today, that meets kind of those basic requirements. Is I guess Universal Robots has the cheapest arm, and I've heard rumors that they cost about like 10 grand.
And
Right.
that's good only for industry, not on a personal robot.
Right.
Whatever
So you
they
can't
have.
put a $10,000 arm on a Roomba-like kind of consumer product, right? So how do you? That's what these Modbot guys are doing. They're making that arm cheaper by integrating those components into a modular kind of component.
Who are these guys?
Modbot. It's
Modbot.
called Modbot.
Thank you.
And we have a time for just one last question because Shahin has a plane to catch.
I don't know if I got the plane, but hopefully. Hopefully I got the flight.
Question? The last one?
We're talking about robots, but you're basically telling us that we shouldn't get involved in hardware. Are robots hardware or software?
It's a very good question. First of all, if there's any takeaway from this meeting, that would be VC money should be the path of last resort. You shouldn't change what you're doing to make yourself attractive to VCs. You should do what you're doing, and if there is a case to be made that with an infusion of 10, 15, 20 million dollars of capital, then your business can be significantly accelerated towards a billion-dollar company, then by all means. But in most cases, that's not going to be, in most circumstances, that won't be the case, right? So that's one kind of takeaway. And then I guess the second takeaway is that hardware by nature is something that takes time, both to implement and to kind of market and build a business with. But there's always, obviously, exceptions, and maybe the person who comes up with a way to decouple the timing, the front end and the back end kind of time and money associated with doing hardware companies, then they would be a very, very kind of good candidate for venture. Is that consistent with what I was saying earlier? Yes. All right. Yeah. Consistency is king.
Yeah. Well, and that was a very good roundup for the whole set of questions and answers. Thank you very much for coming and joining us today.
You guys were a great audience. Thank you, Arthur.